Sure. Can we turn the audience lights a bit up? And now, of course, we're streaming that request live, which I'm sure people in the audience out there really care about. So we're going to do a series of, unlike last year, we had an idea that wouldn't it be nice if we had more talks and make them a little shorter. So we're kind of thinking of these as like thunder talks. And the first one we're going to kick off with is, Andre, and he's going to explode some tuples.
So this is a recurring problem. Oh, by the way, who knows the cultural reference here? The Way of the Exploding Tuple, the oldest people in the room. There's a movie, a cheesy movie in the 80s, The Way of the Exploding Fist. You may want to search for that. It's kind of a funny movie for if you have a dubious taste in movies. So, The Way of the Exploding Tuple. Please note this is a short talk, as Charles said, and actually, I gotta say, short talks are kind of difficult. To wit, Scott said yesterday, I can say my name in less than 10 minutes. And his name is Scott Douglas Myers, like 5 syllables to his name. And for full disclosure, I should tell you my name. Tudor comes from dad. Christian comes from mom. And Andre comes from the gynecologist. I'm not kidding. So the weight went down. The weight went down was, I was born on St. Andrews. And the gynecologist noticed that. And he said, oh, we should call him Andre, too. My mom was, I'm not going to give up on Christian. And my dad was, I'm not going to give up on Tudor. And then they asked the gynecologist, well, is there room on the form? And here we are. All right. So, wonderful. We got to move fast. There's a new thing in C++11, which is these T's and V's. So T's and V's. And one thing that people have sometimes difficulty to come to grips with is that this symbol T's in this slide here, the symbols T's and V's in this slide are not anything comparable to previous C++. It's a new kind of science, a new kind of thing, right? Therefore, the normal rules are you can't copy such a thing. You can't typedef it. You can't say, well, let me typedef this and kind of make it, give it an alias, give it a different name. So typedef could be entirely appropriate, it seems, but it's not. Similarly, you can't instantiate such a list of types. You can't say, well, T's, let me create a value of this type, and it presumably has an instance of each type and stuff. And that, again, doesn't work. And you can't, of course, copy the values, even inside this function here, fun. You can't say, well, I have V's, so let me create a local copy of V's, and, So it's a very bizarre thing. And the way you should reason about it is, it's a new thing, which is unlike everything else in C++. And it obeys very specific rules. And the only two things you can do to it is apply size of ... and expand the thing again into in certain places. To make that more palatable for people who actually want tuples of objects, which is sort of a very reasonable thing to strive for, the standard defines tuple, which in this example contains an int, a string, and a double. So it would actually contain these, it's a product type of these 3 types. It contains one instance of each. And then there's a helper function that can create such tuples. And notice that there's this nice, actually it's well written. So this is what I should be saying, because make people notice that it's called with an int, a const char star, sort of a literal string, and a double, and yet it works because of the whole conversion during construction and such. And you can also create a tuple from scratch with auto, and that's even nicer because you don't need to actually specify its type. However, of course, do notice that T1 and T2 have distinct types. They don't have the same type. T2 is going to have type tuple of int, const char star, and double, right? So far, so good. And it's kind of either, heads up you lose or heads down I win and stuff like that, because then we don't have the expansion. So now I have a function that takes an int string and a double, and we have a tuple which kind of stores the parameters, the arguments for the function. And you can say, well, let me expand this tuple into the function call and just have it work. So this doesn't work. Okay. How do you think we should approach this? What would be a solution? So first of all, one solution would be to say fun of get 0 t1, comma get 1 t1, comma get 2 t1, and that actually I write by hand the whole expansion of the arguments, right? We don't want that because in generic functions we don't know how many tuples are in there, and we want to be able to write generic code using tuples and such. And ideas. Loud.
Take a tuple.
Take a tuple. Have fun, take a tuple. So that's a good idea. So that's the second idea. So we had the first idea was actually write the expansion by hand. The second is have fun itself, take a tuple. So that would mean, doing surgery on the function fun. Then if I need to call fun with the 3 arguments, I need to call make tuple before and such. But that's a valid idea. Assuming we can't do surgery on fun, what would be another possibility? Yes?
Write expander adapt where you pass the first parameter function or functional tuple, second parameter tuple, you go and expand.
So write actually a little code that's going to take the function, take the tuple, and explode the tuple into the function call. And it has to be recursive because that's the way tuples work, and that's the way all expansion works in C++. And it's going to have to be carefully written. I talked about this last year about Veridic templates, and I said, I'm going to leave this, what I'm talking about today, as an exercise to the reader. And a gentleman from Sweden or Norway wrote me with a solution. Andrew Sutton also was very kind to send me his, which is actually in the public domain. I'm not sure it's available online. An internet Facebook also wrote one, so I've had an embarrassment of riches of sources of inspiration. So it's one of those problems that comes about on and again, and I think it's a good opportunity for this short talk to kind of say this. Let's look at how it could be done. For this, I'm going to define an expander. So this is the important case. This is sort of the central slide of this all. And the way this works is I'm going to define a structure that is parameterized on k, which is my counter. Like expand this tuple starting from here. The tuple of this size, k is the size of in the iteration. R would be the return type of the function. Tup would be the tuple class. So tup is kind of looks generic, but it must be a tuple of something. Inside, and this is sort of the key thing, I have a different template which takes variadic use. And that's sort of my in-flight expansion that's ongoing right now. OK, so expand, and we take the function, we take our value reference to the tuple, and we take the arguments. And inside, this is going to be one sort of stage of the rocket, right? One step in the expansion, which is going to say, well, return expander, bump the counter down, take the last argument and forward it. That's get. Take the tuple and forward it, so just pass it along. The interesting part is get of the last field of the tuple, k-1, and forward the tuple to it. And in the end, I'm going to say forward args. OK. So I know there's a mouthful here. So raise your hand if the last line makes any sense whatsoever to you. Okay, it doesn't make to me either, so let me explain it. Dot, dot, dot to the right of an expression means do this for everything. So for the US args, the compiler is going to see dot, dot, dot prefixed by that particular expression. And what it's going to do is the following. It's going to say, what are my lists here, my parameter packs? There's two. One is US, us, and one is args. And the way this is going to work, the compiler is going to say, for each of these variadics in lockstep, just expand that stuff. And by the way, if you see the comma, after a get k-1 forward t, there's a comma. And it just so turns out the compiler is smart enough that if there's nothing to expand, it's going to back off a little bit and delete that comma. It's going to be like, oh, there's nothing here, so that comma wouldn't make much sense, would it? So let me just ignore it gloriously. It's kind of a counterintuitive device. It does work, but it's highly counterintuitive. So what am I doing here is I take the k-1 argument of the function. I'm going to put it in the list, and I'm going to also pass forward the arguments. So what effectively happens is that the expander k-1 is going to get smaller k, but more arguments in the argument list. So this is the crucial part, is that I'm taking, I can't show with this, no, it doesn't make sense on the webcast. But essentially, the last two lines mean kind of expand one argument and continue passing the other arguments. And there's going to be a limit case at expander 0, right? So okay, so far do we have an understanding? So k would be sort of my iteration. I start at the end of the list and I kind of iterate backwards, because it's k-1, k-1, and so on. And what I'm expanding here, I'm passing along the function of the tuple and whatnot. And what I'm going to do is increase the actual US ... args. I'm increasing that guy by 1. I'm bumping down the counter, and I'm passing forward the other arguments as they were. Make sense? Yes? Args is what's already been expanded. Initially, there's going to be 0 args in there. There's going to be nothing, and the compiler is going to do the trickaroo with removing the comma. And after the first step, I'm going to have 1 argument, and I'm going to pass the rest. And after the second step, I'm going to have 2 arguments, and so on, right? And the only thing that we need to be kind of suspicious a bit about is that I have 2 forward t. I have forward t and forward t twice for the same tuple. But sort of, I'll explain how this actually is meaningful. Any other? Yes?
So there's a couple of typos that are pretty important. So in the function signature to expand, you have use ... That should be use ref ... Otherwise, you're not actually perfectly forwarding your arguments.
Let me repeat the first typo. So there's 2 typos, one of which Eric just noticed. Probably the second is, I hope it's not the third. So I should have put US, use ampersand. So I can kind of, it's a universal reference kind of thing, and it just works for every kind of R value, L value. So in the argument list of expand, you should take R value to F, R value reference to F. You should take, as I take an R value to tup, and I should take indeed use ampersand. And the second? You need to specify a template parameter for forward. How did that disappear? Okay, it was in my code samples, but you gotta say forward tup. And how did that compile? I remember I was talking yesterday with someone and said, forward is a disaster if you don't specify the parameters. And they said, no, it shouldn't compile. And apparently it does, which is kind of weird. Okay, so that shouldn't compile. And so the comment, there's two comments. One is use in the argument for expand, parameter list for expand should have ampersand because I want to forward transparently. And second, forward should have tup as an explicit argument there. All right, let's see the limit case now, which has the, oh, in this case I did remember forward. This is nice. Okay, so in this limit case I have expander of 0, which is I'm done with the tuple. I'm done with the expansion. And at this point, I actually call the function. I get to call the function. And again, there's this whole forwarding thing, this whole nice expansion. But at this point, after I've worked my way backwards through the list, I'm having everything in the form of a nice ... kind of thing, which is now exploded. So there are a few loose ends. I mean, this would be kind of difficult to use with all these parameters and stuff. So let's make it more. Let's put a shell around it, which I can even call explode because that's the theme of this talk. And I'm exploding, for this function and this tuple, I'm going to invoke the function with the tuple. And the first overload I wrote here takes a const reference to a tuple. There are three explosions. There are three explodes. One is for const, one is for L values, the other is for R values. So I wrote 3. Nice enough, they're all like one-liners. In C++ lingo, one-liner can be like 80 lines, right? So they're one-liners in theory. They have one semicolon each, okay? So this is the second ever useful use of size of ... I have return expander. I'm passing the whole size of the tuple as the initial counter. Remember, that's the k that I had. Because I'm starting at the last guy and I'm kind of working my way back. And then I'm passing the result of the function, the type that would be returned by the function, which is nicely computed with std result of. I'm passing f, the function type, which is a reference to a function most of the time, or functor, or lambda. And I'm passing const tuple t's reference as my tup. This is tup in the slide above. And I'm calling expand against all that. So here, there's no trick. I mean, it's const reference. There's no need to kind of worry about forwarding and moving stuff and all that jazz. So this is sort of the simplest example. Is this make sense? Yes.
So I have a question. So why do you forward this tuple key since you always pass the L value to
Why do I need to forward?
tuple key inside this expand?
Here?
Yeah.
Oh, because this should work for everything. I don't want to copy this code for const, non-const, const L value and R value. I don't want to copy this code. I don't want to duplicate this code. So this should work for everybody, right? So that's forward is going to do essentially nothing for const references. All right. Okay. So that was the first one, the const. I'm just going to pass a constant tuple, no problem, no worries here. Now, the more interesting case is if I want to pass an L value, then I'm going to say, well, it's an L value, so let me just do pretty much the same. That's not the interesting case, sorry. So this is uninteresting, this is uninteresting, and this is interesting. And I'm looking for Eric's hand in the air to see any major mistakes I might have. No hand? Yes. Destroy. Oh, STL. Okay. Shoot.
Can you go back to like side 12?
Side 12 is the one I was afraid of.
I have objections.
Huh?
There's 2.
Yes.
First objection, result of is wrong.
Result of.
The problem is that you have a const tuple ref and you're getting things out of it. If you look at the signature of get, this will apply a constant ref. So if you have a tuple of like int ref, the get will return constant ref. So by passing the TS unmodified, you are asking for the
I understand. That is okay. And there's no simple solution to this.
There is a simple solution.
Oh, we.
Second is that
You gotta tell the solution, man. I mean. Okay, so let me repeat for the webcast. So STL's first objection, out of I hope 1.5. Okay. So STL's first objection was the result of is going to compute the wrong thing because I'm passing the function and I'm passing the t's, but the t's, there might be some conversion there for calling the function involved. And f of t's does not really compute in all cases. And the fix for that is?
so the fix for it is to throw out all of your code.
Throw away all of the code that doesn't start well. And?
Unless you've got this in a later slide, like you're peeling off the arguments one by one, and then eventually, in your final non-recursive call, you invoke the function. There's a way to do this in a single variadic blast. You compute an index sequence. It was voted in C++ 14. Jonathan Wakely's index sequence 4. You just say index sequence 4, bunch of types, and then you call one helper function, and a single variadic blast you call the function.
Okay. So let me repeat my understanding of what STL said. He said, throw your code away and take a sabbatical until 2014 when C++ 14 is going to be in vigor. And at that point in time, there's going to be a simple solution in the standard. So,
You write the index sequence yourself. It's like a 2 line. It's not that.
yeah, so actually this is fixable. So, this result of, I actually sat down and wanted to define my own, but I didn't have time because last night, drink buddies with Bjarne, drink buddies with Charles, drink buddies with Walt. I mean, I was like, there's a couple of vines each. And, last night I was like, I'm going to wake up early this morning and I'm going to fix this. And you know what, Okay, so last but not least, which is sort of the one interesting tidbit here, is that I'm having this interesting case in which I'm passing an R-value tuple into this expand thing. So in this case, I'm going to say, well, I want to move the guy because it's an organ donor by this point, right? I'm going to move away from this tuple. And the nice thing is that the whole forward with the type and everything, the whole forward thing and the whole get thing, get is written cleverly. So get, this is std get, So get is cleverly written such that for an R-value tuple, it's going to return an R-value reference, which means the tuple is going to get progressively disemboweled and extracted. The organs are going to be harvested from progressively by the template. Gotta love templates, right? I mean, and all this move construction. So it's going to be progressively taken away from, and at the end, the function is going to get the R values or whatever was in the tuple, and in a very nice form for the appropriate action. So it's going to be efficient. With this, so this was sort of the interesting tidbit. One thing that needs to be made, we need to make sure it works. So call move here, and whenever you expand, you got to kind of pass forward. Where are we? Like you got to pass forward here, got to pass forward here. That's why you need all these forwards, just to make sure the whole flow goes the right way. With this, I'm seeing Herb impatiently signaling me. To give you an example, this actually does work. So, this is kind of weird that it works with forward the way it was, GCC 4.8. Probably I should have used Clang. So I have a function, and I'm having a tuple, which is T1 is a regular tuple, T2 is a constant tuple, and T3 has no name. The last example is going to be an R-value tuple, and they all work appropriately. Now, by the way, I need to add the soapbox here because I'm minus 4 minutes. I still have minus 4 minutes to go. I should add, you're going to pry unsigned out of my cold dead hands. I love unsigned types. There's this unanimous advice passed yesterday. Oh, avoid unsigned, and I'm using it. And with this, call the destructors. We have time for minus few questions.
Anyone not have a question?
Anyone not having a question?
Okay, raise your hand if you don't have a question. Cool. No, the other thing we can do is you can answer the question, and then we could do what Herb was planning to do either at the beginning of the panel, or we do it now at a truncated time. So we'll do it now. But
Okay.
Andre, thank you so much, man.
Thank you, guys. Thanks very much. Appreciate it.